I didn't say, I'm Robert, I'm going to be your nerd in charge tonight. Our regular host, Louise, normally does a great bit here about what it means to be a nerd. I thought, in the interest of show, don't tell, I'd just do a 10-minute talk about calculators. That wasn't a joke, I made slides. We're stuck with it, we've got to strap in. So who's brought their calculator tonight? Yeah, it's a trick question because everyone has, because your phone has one. Who's bought 2 calculators tonight? Just me, yeah, fine. I'm not going to be talking about these kind of calculators. These are the electronic ones that we all use. Not so often anymore because we use our phones. But if we grew up after 1970, everyone in school, everywhere else uses it. But before that, we had different ways to do our maths, and that's the kind of thing I'm going to talk about tonight. So, something you're probably all familiar with, the abacus. It's like maybe the oldest calculating machine of any kind. Estimates put it like 2,000 to 5,000 years old. Obviously it's hard to get really accurate data from that long ago. And it kind of grew out of the idea of just moving pebbles along a table, which you can imagine just strapping a wire to that makes it a bit simpler, but you don't really get enough evidence to say they definitely did this at any particular time. And actually, the interesting fact that's probably going to make your head hurt if you think about it too much, these are older than our modern numbers. So by modern numbers, I mean base 10 place value, where you say like, this top one's units, this one's tens, this one's hundreds. That didn't exist when they were first using abacus. It was just like basic counting, the same as you do on your fingers, for example. If you grew up around Europe, you probably just think of this as like a maths toy. In fact, this image from Amazon was advertised as mathematical toy, age 3, 4, 5, 6 years. So we're not doing powerful sums with this. But if you grew up in kind of Japan, China, you may be more familiar with this kind of abacus. These are actually not so much seen as toys, these are much more powerful calculating machines. They learn all sorts of clever tricks to do more advanced sums than just like adding and counting. A couple of key differences, you'll notice the Western one has 9 or 10 per row. The Japanese one there only has a row of 1 and a row of 4. The ones on the row of 1 represent 5 each, so you still get up to 9 per row, but there's a lot less movement of beads to do any number. So it's generally a lot faster. Also the wires are much shorter, just makes it faster. And you've got these like nice diamond-shaped beads. You can just run your finger down the middle and everything will fly out. It's very satisfying. And also makes you very fast at doing the calculations. So while we're on the subject of big, fast calculations, you may have heard this fact. It floats around these badly researched websites where it's like a skilled person on an abacus is faster than an electronic calculator. This is something I hear pretty much that exact wording in many places. I don't know why they chose that exact wording, because it's kind of implying that the abacus has a person, but the calculator is just acting autonomously. But maybe with some more context, you can evaluate it clearly a bit better. So the truth is, that was based on one experiment in 1946. If you try to imagine an electronic calculator in 1946, it's probably going to be very big, hard to use, and slow. That experiment hasn't been repeated since. So if you take that as evidence that the claim is true, then maybe it's still true. It hasn't been disproven. But yeah, these abacuses still live on in Japan especially. Stuff like this exists. This is a combined calculator abacus. I don't know why. I don't think they still make these, but you can still get these. Yeah, something. Japan. Yes, if you grew up here before 1970, you may remember this. I'm not going to name and shame anyone in the audience. But the idea here is you probably can't see it at all, but it just looks like a ruler, but the bit in the middle slides. And the way this kind of works is, yeah, you really can't see, even I can't see, and I'm right here. But the numbers aren't evenly spaced. So there's the 1, there's the 2, and there's the 3. So each successive number is getting closer together. So basically all it's doing is converting regular numbers to logarithms. And You don't need to know what logarithms are, but just there's some maths that you can do which lets you do things like avert multiplications to additions, powers to multiplications. So it just lets you turn hard problems into simple problems using these logarithms. This particular slide rule is quite an interesting one because it's been to the moon. This is actually Buzz Aldrin's slide rule, second man to walk on the moon. This is because back in 1969, even like NASA didn't have powerful electronic calculators, so they decided to send slide rules. And Buzz Aldrin was like the rocket scientist guy, the smart one. So I've heard reports that we only landed on the moon because he was able to do some last-minute calculations on this, but it's probably embellishment. I can't find enough good data. But still, this one fetched $77,000 in auction, so it's a good slide rule. Probably no one has used these since. They're actually now quite hard to buy online unless you want to spend $77,000. Because that's the kind of nerd I am. So, next machine I need to talk about. You may have heard about this as being the first calculator or the first computer. It was discovered in a shipwreck off the coast of one of the Greek islands, Antikythera. Again, you can't really see the details, but we know it's from like at least 100 BC because we can date other stuff that was found on the shipwreck. Probably everything was from around the same time. But it's actually, like, if you can see the picture better, you'll be able to see there's really intricate gears. This is a big bronze wheel and it's got teeth all around it and they're all the same size and shape, and for a long time it was a big mystery, like how did they make it? Also, why is there nothing else like it from that time period? There isn't even anything else like it from hundreds of years later, so it just kind of appeared in the record. So there's still a bit of mystery about where it comes from, but I think there's now fairly good evidence that there was lots of stuff like this at the time, but most of it got melted down after the Roman Empire fell, and this one only survived because it was on a shipwreck. I don't want to spend too long talking about it because it's actually not really a calculator. It's kind of more like a calendar. I can't really describe it very well, but it would have like model of the solar system. You could predict moon cycles, eclipses. So really sophisticated stuff just with gears and machinery. So well worth watching more about. There's some good talks I've seen. Okay, proper mechanical calculators. This is what you've all come for. This is like late or post-Renaissance when clockwork's really big and also automatons are really big. So this is the idea of building something in clockwork where you can wind it up and it will write or dance or play chess or something. And one of the applications of this was calculators. This was by Blaise Pascal, who was a French philosopher and also a triangle fan. If triangle's cool, I would like to have a triangle named after myself. The way this works actually is quite simple. I will in a second. It's very similar to one of these kind of clicker counter things. So the clicker counter thing, you press the button, it knocks on the dial on the end. If that gets to 9, it will knock on the next one, so it'll go up to 10. That's what all of these wheels here do, except you can turn any of them individually. So you don't just have to go one at a time, you can do like 50 by turning that one 5 places. So it's only really good for doing quite simple adding that you could probably do faster by hand. It was still more in the kind of toy than useful tool, although he did manage to sell a few, I think, to governments. There's still a few dotted around the world. It was the first mechanical calculator ever sold. There's also a really nice feature which makes it a bit more useful, which is you don't have to have all of these being 10. This one there are all 10 because this is a scientific model, but if you had, say, 12 pence to the shilling, 20 shillings to the pound, because it's 1642 and you haven't done decimalisation yet, you could just take the last wheel, turn it into a 12, that one turn it into a 20, and then you could add up numbers in varying denominations of pence and shillings and pounds, and they'd all just add up properly. So that made it a bit more useful. There was also a version that did like surveyor measurements. So yeah, there are a few different variants. They're pretty much all now in one museum in Paris. So if you want to see one, they're quite hard to find. if we go, not much actually happened in mechanical calculators for another kind of 200 years. But by then we got to this lovely thing. So this is the first mass-produced mechanical calculator, and the first one that would actually be seen as more powerful than what a human could do just on a pen and paper in that time. It's kind of similar looking to the last one, so instead of the dials you have these little levers, and then you have one big turning handle. Each time you turn the turning handle, it will take all the lever numbers and add them up. So you could use that to just like keep turning the handles, do multiplication. That was a nice feature. You could also slide this whole thing along top, and if you slide it one place, then turning it does 10, and if you slide it two places, turning it does 100. So you could do like big multiplication sums really quite quickly just with, you just need however many turns, like the sum of the numbers, not the actual number. So this was quite expensive, didn't get used much in like homes or schools, but there's a good chance it would be in your office before 1970s-ish. And again, when the electronic calculators came along, just all of these kind of went to museums or got destroyed, so not too many of them anymore. And that's the last calculator I wanted to show you, so I'll leave you with this terrible pun. And we'll get on to our first speaker. So,